The electromagnetic spectrum is a specific name for the light waves that can be produced. Now, it's called electromagnetic because it has an electric pulse and a magnetic pulse, and the two will propel each other through space. That's the reason a light wave doesn't have to have a medium to travel through. Now, what you see here is the spectrum, the different divisions of the electromagnetic waves. We have radio, infrared, visible, ultraviolet, X-ray, and gamma ray. All of these divisions within the spectrum have specific characteristics that make them what they are. In general, you have low energy and low frequency over here with radio waves, and you go to high frequency and high energy with gamma rays. Now, if you have low frequency, you're going to have a high or a long wavelength. And if you have high frequency, you will have a short wavelength. And that's what these pink waves are representing here. As the frequency increases, the wavelength, the distance between crest to crest, will get shorter. Now, it's important to note that all of them will have the same speed. Light travels in a vacuum at 3.0 times 10 to the 8th meters per second. Notice that visible light is broken down into the acronym Roy G. Biv. Those letters stand for the colors of the rainbow. So now we're going to talk about each individual section. Radio waves is our first division of the electromagnetic spectrum that we're going to look at. You are familiar with the fact that radio has AM and FM, and you also know that you have cellular devices and you have a GPS, global positioning satellites. And all of those use radio waves, but so does microwaves and radar. Now, the microwave is what you have in the microwave oven. The microwaves will make the water in your food vibrate, and that vibration causes the water to heat up, which will in turn make your food warm. Now, radar stands for radio detection and ranging, and it's the highest level of radio waves. Both microwaves and radar belong to the category of radio waves. Microwave are the high energy radio waves, and radar is the highest level energy of microwaves. Now, the size of a radio wave is about the same size as a building or people on this end. Infrared is our next division of our electromagnetic spectrum, and it is literally, it means below red. Infrared means below red. Now, the longest part of the wavelengths of infrared waves are felt as heat, and all of them are invisible. Now, everything produces heat. Even cold objects. Our definition of cold is a relative term. So even cold objects can have heat signatures. And so we can get the heat signature by taking a thermogram of an object. And that thermogram is a picture that is capturing the heat radiating from an object. Now, when you see a picture of a thermogram, white hot heat is the hottest. And black spots on those thermograms are where you have lack of heat radiation. So we have white hot, red hot, orange hot, and so on and so forth. So a violet spot on a thermogram has less heat than a blue spot. Now, it's about the size of a pinpoint for this division, so we've gotten much smaller. Visible light is the smallest division of the electromagnetic spectrum, but it's the one we use the most. It exists as white light, But when it's refracted, it gives us all the wonderful colors of the rainbow. Now, I've shown a picture here of a prism that has white light going into the prism. And when white light goes into another medium, we've learned already that waves will refract when they go through a different material. So when white light goes through this prism, the different wavelengths will be affected differently by the medium. So the shortest wavelengths, the blue, will refract the least, and the longest wavelengths, the red, will be affected the most, and they will refract more. Now, all of that leads us to getting rainbows, but it also helps us explain things like mirages, sunsets, and the reason the sky is blue. And we'll talk about some of those things more in class. Now, visible light is about the size of a protozoan, so again, we're getting much smaller. UV rays, or ultraviolet rays, are used to sterilize medical equipment. We also use them in the chemistry lab to sterilize our goggles that we use on our eyes. We call this thing a UV oven. We bake the material in ultraviolet light. We have to be careful with ultraviolet light because it can cause skin cancer. And the skin cancer is the reason we use UV blocking sunblock to protect us from UVA and UVB rays. And the good thing about sunlight is that it will activate the production of vitamin D in our skin. So we want sun, we just don't want too much sun. Ultraviolet rays are about the size of molecules. That brings us to our last two divisions, X-rays and gamma rays. X-rays are man-made and they penetrate most matter. In fact, that's what we use them to do. They are absorbed by bones and teeth, and so we are able to actually see our skeleton. We have to be careful about being exposed to too much X-ray because if we are, we could produce cancer in our bodies. Engineers will take X-rays of buildings to see if there are hidden cracks in the structure. And X-rays are about the size of atoms. Now, gamma rays are natural and they are harnessed when we use them. They are the greatest energy, highest frequency, lowest wavelength section of the electromagnetic spectrum. We use it for radiation therapy to treat cancer, and we also use it in nuclear weapons. Gamma rays are about the size of atomic nuclei.